Look up at the night sky. Every star you see, and billions you can't, could be hosting a civilization far older, far smarter, and far more powerful than ours. The universe has existed for 13.8 billion years. Earth has been around for 4.5 billion. Human civilization? Barely 10,000 years. A cosmic blink. So the question isn't whether someone else is out there. The question is, where are they? And more importantly, are we next? In 1964, a Soviet astrophysicist named Nikolai Kardashev asked a simple but devastating question. If aliens exist, how would we even recognize them? His answer was elegance itself. Measure them by their energy. Not their weapons, not their ships, their power consumption. He proposed 3 levels. A Type 1 civilization commands every ounce of energy on its home planet. Wind, solar, geothermal, volcanic, nuclear, everything. A Type 2 doesn't just live near a star, it captures the star itself. And a Type 3? That's a civilization that drinks the energy of an entire galaxy. 100 billion stars bent to its will. Here's the uncomfortable truth. On this scale, humanity sits at 0.73. We haven't even cleared level 1. We're a civilization still burning dead plants to keep warm. Now here's where it gets chilling. In 1950, the Nobel Prize-winning physicist Enrico Fermi was having lunch with colleagues. The conversation turned to aliens. Fermi did some quick mental math. Billions of galaxies, each with billions of stars, each star potentially hosting planets. The numbers were overwhelming. Civilizations should be everywhere. Fermi put down his sandwich and said 3 words that have haunted science ever since. Where is everybody? That silence, that vast, deafening 13 billion year silence, became known as the Fermi paradox. The universe should be loud. It's not. And that quiet might be the most terrifying sound in existence. In the 1990s, an economist named Robin Hanson proposed a theory so unsettling it keeps astrophysicists awake at night. He called it the Great Filter. The idea is this. Somewhere between single-celled slime and galaxy-spanning superintelligence, there's a barrier, a wall that almost no civilization can cross. Maybe the filter is behind us. Maybe the leap from chemistry to life was the miracle, and we already survived the hardest part. But what if the filter is ahead of us? What if every civilization reaches our level, splits the atom, builds computers, creates artificial intelligence, and then vanishes? Cold War scientists came within a single phone call of ending humanity with 70,000 nuclear warheads. Today, 12,000 nukes still exist. Climate change is accelerating, and we're building AI systems that even their own creators don't fully understand. What if the Great Filter isn't a comet or a supernova? What if it's the moment a civilization builds something smarter than itself? But let's say we make it. Let's say humanity navigates the bottleneck and reaches Type 1. We crack nuclear fusion, the same process that powers the sun. Infinite clean energy. We control our weather, green our deserts, feed every human being. Then we push further. Type 2. We build what physicist Freeman Dyson imagined in 1960, swarms of mirrors and satellites encircling the sun, drinking its fire. Every planet in the solar system becomes a construction site. Mercury gets mined to the bone for raw materials. And then, the leap that defies imagination. Type 3. A civilization that stretches across the entire Milky Way. 100 billion stars harnessed. The supermassive black hole at our galactic center, Sagittarius A star, becomes a battery. Self-replicating probes called von Neumann machines spread outward like seeds in the wind, colonizing star after star. We wouldn't just be a planet anymore, we'd be a galaxy. But here's the twist nobody wants to hear. If we reach Type 3 and we still find no one, no signals, no megastructures, no traces, then the silence becomes a verdict. It means the Great Filter wasn't just hard, it was nearly universal. And we are either the first to ever cross it, or the last to ever try. Every decision we make with AI this decade, every nuclear weapon we keep pointed at each other, every ton of carbon we dump into our atmosphere, it's not just about saving the planet, it's about whether the universe ever gets to know itself. Because right now, in 13.8 billion years of cosmic history, the universe has produced exactly one species capable of looking up and asking, "Are we alone?" If we disappear, that question dies with us forever.